Hello everyone, welcome to Vijay Chemistry. Today Day-07 class, okay? And today we are going to discuss about what heterocyclic molecular compound. Please note, in exam, they will ask minimum 2 questions, okay? In CUET exam PG level, okay? Listen, now what is heterocyclic molecule? Please understand, first I write this molecule, okay? Now this molecule. Now this is cyclohexane, right? This molecule containing all carbon atom. Right now, I am going to replace, okay, listen, replace one carbon atom, okay, one carbon atom, not only okay, 2 or 3, okay, one carbon atom by heteroatoms. By heteroatoms. Now, what is challenge? What is heteroatom? Please note. Nitrogen, sulfur, oxygen. Okay, this is heteroatom. Okay, other than carbon is heteroatom, right? Now I'm going to change this like, okay, please understand. Now I put this molecule. 1, 2, 3. Okay, now this is heterocyclic molecule. This is a heterocyclic compound. Okay. Now what is heterocyclic compound? The compound, okay, is replaced by what? One carbon atom by heteroatom. Okay. Not only one carbon atom, okay. It can be two carbon atom, it can be 3 carbon atom, okay. Now best example, this is benzene, right? 1, 2, 3. This is benzene. Now I'm going to replace one carbon to nitrogen atom, okay. Now minus carbon and plus nitrogen. Now see this molecule. This is pyridine. Some people call pyridine. This is a pyridine. This is a benzene. This is carbocyclic molecule. Carbocyclic compound. What is carbocyclic compound? Only containing carbon atom. Okay. This is what? Heterocyclic molecule. This is a heterocyclic compound. Now understand, okay? What is heterocyclic compound? Okay. One of the carbon atom can replaced by the other than heteroatom. What is heteroatom? Now? Nitrogen, sulfur, oxygen, etc. Okay. Now, okay, I give you the example. Okay, for example, heteroatom. Okay, benzene. See. Now, pyridine. Now I'm going to challenge. I'm going to find out the pi electron density. Okay, please note. Very important. Pi electron density. Pi electron density. It means what? More electron rich species. Now, what is our challenge? We are going to find out, okay, benzene and pyridine, which is more electron rich species. Okay, what is the formula? Please note. Formula is number of pi electron divided by number of hydrogen atom. Number of hydrogen atom. Wait, this hydrogen, okay? This hydrogen atom, please note. This is hydrogen atom. Now, in case of benzene, how many pi bond? 3 pi bond, therefore 6 pi electrons. How many hydrogen? 6 hydrogen. The answer is 1. Okay. In case of pyridine, okay, number of pi electron, 3 pi bonds again, 6 electron. This is 5. The answer is what? Around 1 point. Okay. 1 remaining 1 of 1.2. Yes or no? Therefore, the pyridine, the more electron rich as compared to benzene. Therefore, please note, therefore, the electrophilic substitution reaction is faster in which one? Faster in pyridine. Why pyridine? Because pyridine is what? The more electron rich group. Okay. Now I give the question, you can tell the answer. I give the 4 molecule. We have tell which undergo more electrophilic substitution reaction. Okay. Now this is okay. Pyrrole. It's a challenging question. This is Furan, sorry. This is Furan. This is Pyrrole. This is NH. Okay. This is thiol. This is what? This is Pyrrole. Some people call Pyrrole. This is what? Thiol. Among these 3 molecules, what are the questions asked? Please note. First question, okay, dipole moment order. We have to know. Okay. And second question, aromaticity. And third question, rate of electrophilic substitution reaction. Okay. These 3 questions very challenging question. Okay. We just try to answer 3 questions. Okay. Aromaticity is simple, right? We have to know, listen, is obey the 4n plus, listen, aromaticity, I upload already video in our YouTube channel, right? You go and check the playlist. I completed, complete the aromaticity I completed, okay? Complete aromaticity, okay? I teach already. You check on playlist, okay? If you want to learn aromaticity, please learn it, okay? A rate of substitution, I will teach later, okay? Now, please note, okay? In, listen, note. Same, this also you can try. I take Pyrrole, same, right? This is Pyrrole. This is Pyrrole. Just wait. This is a Pyrrole. Now this is benzene. Among these two, which is a more rate of electrophilic substitution reaction? Now same, first you have to find the pi electron density, right? What is pi electron density? There are how many pi bonds? Listen, this lone pair involving resonance, okay? Please understand. Therefore, 2 plus 2 plus 6, okay? How many carbon? Hydrogen, 1, 2, 3, 4, 5. Yes, our answer is 1.2. In this benzene, you know, right? 6 bases, answer is 1. Again, what? Again, which is more rate of electron substitution. Pyrrole is what? Pyrrole is the more as compared to the benzene. Now, what is challenge question? We are going to take pyrrole and benzene and pyridine. Okay. Now, which is more electron density? Okay. That is explained by what? Aromaticity. Okay. You just try to answer the question. Please watch aromaticity video. Then only able to try the question. Okay. The simplest and basic question. Now, listen. Now, what is our challenge? Now, I'm going to discuss about what? Pyrrole and listen. They're important. Please note the important heterocyclic compound. Heterocyclic compound. What are the important? Now, first one, Pyrrole. Please note. Pyrrole. Second one is Furan. And third one is Pyridine. And the fourth one is what? Pyridine oxide. Pyridine N oxide. Okay. And sixth one is indole. And last one is isoquinoline. Okay. Listen, this 1, 2, 3, 4, and 5 and 6. Okay. This 6 is very, very important. What is our challenge going to learn now? Okay, in this Pyrrole, okay, we have to know structure bus 1. Okay. Now if we do the electrophilic substitution, listen, all molecule undergo what? Electrophilic substitution reaction, right? If you take Pyrrole, okay, if you do electrophilic substitution reaction now, where is the position of electron going to attack? That's a challenge we have to find out. Okay. That I'm going to teach now. Please note. First one, Pyrrole. Okay. Now formula. It's a formula, right? NH. Molecular formula C5H5 1N. This is a molecular formula of Pyrrole, right? Now see. Now please wait. Note. This is the first question. Okay. Listen. This is very important. Please note. This question is number 1. Is number 2. Is number 3. Is number 4. Is number 5. Okay. The question of what? Pyrrole. Okay. Now please note the electrophilic substitution reaction in Pyrrole. Okay. This take place. Electrophilic, the substitution reaction order, which is more rated. Second, fifth, அதுக்கப்புறம் third. Actually பார்த்தோம்னா listen, 2 5 same, right? இல்லையா? அதே மாதிரி 3 4 same. Okay. Listen, which portion under substitution reaction going to take place? Second portion. Okay. Now I give the example. Please note 1, 2. Okay. Now here H, here Pyrrole. Okay. Now I going to add this reaction. Okay. Tell me name of the reaction. This one, add chloroform, CCl3 and KOH. What is the reaction? It's a Riemann-Dimer reaction, right? Now, what is incoming group? What is electrophile? Dichlorocarbon, right? What is electrophile in this reaction? Cl2. Okay, now what is the answer for this question? Now, nitrogen, 1, 1, hydrogen. Here, what? Here, CH. Okay, this is what? This is a in the position CH introduce second position, right? In this reaction, the electrophile going to attack in the second position of Pyrrole. Okay. Suppose second position is what occupied, then go with the fifth position. Okay. Suppose second and fifth position occupied, go with the third position. Okay. Now see, one more is very, very important. Please know one more example. Okay. That is called Manish reaction. Please know naming reaction. That is Manish reaction. Okay, what is a reagent in managed reaction? Simple. Formaldehyde. Okay, and plus secondary amine, that is N, methyl and methyl and H. Secondary amine and plus H plus. Okay, now what going to happen? Please note, initially they form this line. Okay, CH2 and double bond and nitrogen, here CH3 and CH3. It having positive. Right? Now they shifted to here. Now what going to happen? Here CH2 plus nitrogen, here CH3 in CH3. Okay. Now see, in this managed reaction, okay, in this managed reaction, what is the electrophile? Please note. Okay, this is what this is electrophile. Please note. Okay, this is here the electrophile in the managed reaction. Okay, this is electrophile in the managed reaction. Okay, what is the reagent? This is a reagent part. This is a reagent. This is here the reagent. Okay, formaldehyde and secondary amine with what H plus. Okay, now I do the one reaction. See, take pyrrole, same. Take pyrrole, here nitrogen. Okay, lone pair. Now, if I add this like, for example, SCHO, okay, then H, N, Me twice, and H plus. Now, what is the product? This is a product. Nitrogen, here H, lone pair. Now, here CH2 and N, here CH3 and CH. Okay, this is the product for the managed reaction, right? Whenever the naming reaction, first we have to know which type of reaction. Okay, it can be electrophile substitution reaction, the oxidation reaction. Okay, then we need to find out the type of the reaction. Then which type now? For example, electrophile substitution reaction. Now, next what is the target? You have to find which is electrophile. Okay, now what is this target? Where is the position of electrophile going to attack to the substrate? Okay, this we have to know. Now we can find out the product very easily. Okay, now I give one more reaction, very important. Please note. Okay, this is very important reaction. Okay, now same. Sorry, take pyrrole. Listen, in the managed reaction, removing reaction is common for all electrocycle molecules, right? The position only different, okay? Intake of pyrrole, second position can be occupied, right? In case of pyrrole, okay, different position. In case of pyridine, different position, okay? In this reaction, okay, the naming reactions they give the same product, but naming reaction give the same product only, okay? But where is the substitution of electrophile going to attack only the different, okay? Please understand. Now, POCl3. Okay, and D of dimethyl formamide, then H2O. Okay, anyone tell the name of this reaction? Okay, this what is a reagent? This is a reagent. Okay, now tell me what is the name of this reaction? Okay, it's a very, very important reaction. The name starts from V. Okay, it's like a quiz. You tell the answer. Okay, now listen. Now in this reaction, what is electrophile? Same. Okay, what is electrophile? CH2 and double bond. Okay, wait. This is why this actually formalization reaction. This actually what? Actually, the formalization reaction. Formalization reaction. What is formulation reaction? Introduce the CHO group, aldehyde, CHO group. Okay. Now same, right? Simple reaction. Now tell the answer simple, right? Take pyrrole, put POCl3 and DMF solvent plus water. And what is the answer? Second portion, what aldehyde going to attack? Okay. CH. Okay. This about what? This about what? This about the pyrrole. Okay. This is a substitution reaction. Now very important. Please note reduction. Very important. Okay. Now listen. If you use hydrogen and nickel, okay, this is used for specifically for reduction of aromatic compound. Reduction of aromatic compound. Okay. Now see, if I take pyrrole, okay, use hydrogen and nickel. What is going to happen? How double bond going to reduce? This is this answer. Okay. Same. Okay. Very simple, right? Now, this is very important. Please note. Exam point. So most important. This question can ask in exam anytime. Okay. Now, take pyrrole. take Pyrrole. I'm going to do the bromination, okay? I add Br2. But I'm going to change the solvent. Okay? Here I use non-hydrolytic solvent. Non-hydrolytic solvent. H plus solvent, okay? Not hydrolytic solvent. Okay. Where is a Br plus going to attack in the reaction? A second position, right? Well, this is 1, this is 2, right? This is third, this is 4, this is 5. The second position. What is the answer here? I get the answer this like. This is Br. If I use, please understand, if I use Br2 in acidic, in what? In the H plus medium, for example, ethanol or water, okay? This is a protic, okay? This is hydrolytic medium. Okay, this is what is non-hydrolytic now. Don't give H plus. Okay, if you give the H plus donor solvent, okay, all portion can get the bromine dead. Okay, now what is the product? Please note. Simple. Very important, most important. Nitrogen dot, okay, lone pair. Here Br, here Br, here Br, here Br. Okay, this is very important question. Please understand. Very important. Okay, this about this about what? This about the, okay, Pyrrole. Now next I go with the Furan. Please note, same basic one. Listen, you what the reaction I teach, what are the reaction I will teach taught abina, Riemann reaction, Mannish reaction, POCl DMF reaction. Okay, that reaction common for Furan. Okay, all the reactions are common only. Okay, what I told earlier now, the substitution of electron going to attack is different. Mathematics pata ellame same da. Okay, now note, please note Furan. Okay, now what is the molecular formula? Simple oxygen, right? This is Furan. Okay, now please note, it is less aromatic. It is less aromatic than Pyrrole. Why? What is the reason? C. Very simple. Lone pair. Here also what? Having lone pair. Now see, in both cases, okay, both cases, this lone pair not involving resonance. Okay, which lone pair involving resonance? Listen, only this lone pair. Please note, okay, only this lone pair. Okay, I change the color. See, only this lone pair. Only this lone pair involving resonance. Okay. Now listen, if whenever this lone pair involving resonance, it means 1, 2 plus 2 plus 6. Okay, 6 pi electron. Obey what? The 4n plus 2 pi electron, right? This occurs to the aromatic compound. Okay. Therefore, in case of nitrogen and oxygen, which is gives a more donor ability, please know, okay, the electron of oxygen higher than nitrogen. Therefore, okay, the oxygen not able to give the electron as much compared to the nitrogen atom. Okay. Therefore, the nitrogen electron, lone pair electron, easily involving the resonance. It means what? The Pyrrole is what? The more aromatic as compared to what? Furan. Okay. This reason what? This reason the Furan is less aromatic compared to Pyrrole. Okay. Please understand. I tell the answer. First question I tell the answer. Which is more aromatic? Which is more aromatic? The Pyrrole is more aromatic. Sorry. Pyrrole is more aromatic compared to the Furan. Okay. Now listen. Note. Actually, listen. இது பாத்தீங்கன்னா ஆக்சுவலா ரியாக்ஷன் இருக்கும். இதுல nitrogen H. Okay. This is chloroform and KOH. In this reaction, please note, ring expansion will take place. Ring expansion will take place. It means they form 6-member ring. Okay. You try to answer for this question. Very important question. Okay. Very important question. Okay. Why the ring expansion will take place? Not due to the more electron density. Okay. Okay. More electron density. Okay. But in Furan, the ring expansion does not take place. Does not take place as compared to Pyrrole. What is reason now? The electron density, which is higher. Pyrrole is higher as compared to Furan. What is the reason? Electron. Okay, listen. Both Pyrrole and both Pyrrole. Okay, listen, understand. Okay. This two molecule, okay, this two molecule, okay, the oxygen atom more electronegativity, okay. Due to the more electronegativity, the Pyrrole is electron deficient compared to Furan is electron deficient compared to Pyran, okay, compared to the Pyrrole, okay. Due to electron deficiency, Furan not undergo ring expansion, but Pyrrole undergo expansion, okay. This answer is what? This like answer you will get answer. Please note. Okay. In case of Pyridine, this very, very important. Okay. 1, 2, 3. This answer you check. For this question, okay, this all together, okay, this all together. Okay, this answer for what? Answer for this question. This CHO. This is very important one. CHO going to attack that question. CHO. This is the reaction. Now. Now. Electrophilic substitution order. Electrophilic substitution reaction order. Same adhe marda. Okay. Second, fifth, third. Same. Okay, same. Okay. Now, I'm going to teach one more important reaction. Please note. That is called temperature dependent. Temperature dependent reaction. Okay. In case of what? Just wait. Just wait. Okay. I discuss later this one. Wait. Now, same as the what? Same as the Furan. Pyrrole, I will discuss the Br2 reaction. Okay. Reaction with Br2. Just wait. Just wait a minute. Okay. Reaction with Br. Same reaction. Okay. Take Furan. Okay. Same. Put Br2 methanol. Okay. This is a nitric solvent. In this reaction, please. It's a different product. Here OME. Listen, in case of Pyrrole, okay, if we have some protic medium, okay, we get all position can substituted, right? It's a reverse in the Furan, okay? Because of what? Because of the Furan is less electron density, okay? This Br2. In Br2 is a non-hydrolytic solvent, okay? Non-hydrolytic solvent. Hydrolytic solvent. In this case, all portion get Br2 can substituted. In case of Furan. But in case of Pyrrole, what? It's a reverse. Here we are. Okay, this is the most important. Please, this is a exam point of EPOV. What is EPOV? Exam point of view. Okay, this about the Furan. Okay, now next I go into this is very important. This is called what? Pyridine. Please note. Pyridine. Some people call pyridine. Pyridine. What is the molecular formula? 1, 2, 3, 4. Nitrogen. 1, 2, 3, 4. C5. H5. Again, this is a pyridine. Okay, now electrophilic substitution order. Please know, a very important order. Okay, which is more rate. Okay, Pyrrole first. அதுக்கப்புறம் பென்சீன் கடைசியா வந்து pyridine. ஏன் பென்சீன் அதிகம்னா நைட்ரஜன் இன் கேஸ் ஆஃப் பென்சீன்ல ஆல் கார்பன் ஆட்டம் ரைட். இன் கேஸ் ஆஃப் நைட்ரஜன் pyridine நைட்ரஜன் ஆட்டம் இருக்குமா? we know right the electronegativity of nitrogen higher than the oxygen, right? Higher than carbon atom. Therefore what? This nitrogen pyridine is less electron density as compared to what? Benzene atom. Whenever the molecule have a more electron density, undergo the more rate of electrophilic substitution. Okay, listen. Whenever the molecule undergo electrophilic substitution, that reactant must be the more electron density. Okay. In case of pyridine, they have nitrogen. In case of benzene, they have carbon atom. Okay. We know that the nitrogen has a more electronegativity than carbon atom. Therefore, the pyridine has less electron density as compared to benzene. Okay. Due to what? Due to the electrophilic substitution take place benzene as compared to pyridine. Okay, this is a very, very, very important reaction. Okay, now in case of benzene, where is the position? So pyridine. 1, 2, 3. This is 1. This is 2. This is 3 and 4 and 5. In this, okay, 2 and 6 are equivalent, right? Equivalent. And 3 and 5 are equivalent. equivalent, right? Now, please note. Very important. Note. Most important. Note. The electrophilic substitution reaction. Attack. Where is the portion going to attack in pyridine? Okay. Third as compared to 5. Suppose third is occupied, then go with the 5. Okay. Nuclear substitution. Nucleophilic attack. Attack. What is the position? Please note. You can go into attack what? Two position, to second, third, fourth, sixth position. Okay. Please note. Okay. That's very important point. Note. Note. In pyridine. Okay, the electrophilic substitution reaction take place as drastic condition. Drastic, DRA, drastic. Okay, upon high temperature, high pressure, drastic condition only. This is very, very important. Okay, now very important reaction, Chichiban reaction. Okay, in case of what? Pyridine. This is very, very important. Naming reaction. Chichibibin reaction. Okay, what is the reagent in this reaction? Please know the reagent. Okay, that is sodamide, NaNH2, and ammonia, and just eat. Okay, now this is a nucleophilic substitution reaction. A type of the nucleophilic and substitution reaction. Okay, now what is the reaction? Please note. Take pyridine. Take pyridine. Okay, react with what? React with NaNH2 and ammonia, and just eat. Okay, where is a nuclear substitution reaction take place in pyridine? Second position, right? Second occupy in the fourth occupy in the sixth. Okay, after second or fourth, sixth, same nala. Right? What is the answer? This is the answer, please. This is NH2. This introduce what? The NH2 group in the pyridine. Okay, this is a Chichiban reaction. Very, very important. It's a type of what? A type of nucleophilic substitution reaction. Okay, now next important. Bridge reaction. Bridge reaction. What is the reagent we can use? Okay, sodium in liquid ammonia. Sodium in liquid ammonia. This is a reagent. Okay, now simple reaction. Okay, now in the case of pyridine, okay, we can use a bridge reaction. Sodium in liquid ammonia. Okay, listen. They form the 3 double bond under 2 double bond. Okay, this slide. This is very important reaction. Okay, this is a product. Okay, same. Listen. Now this listen. Next one, the catalytic hydrogenation. Catalytic hydrogenation. Like what? Like hydrogen, hydrogen nickel, we can use Pyrrole, right? Same as we can use hydrogen and nickel. Okay, catalytic hydrogenation. Okay, now see the reaction. Very simple. Take pyridine. You put lone pair outside ring because this lone pair not doing resonance, right? This lone pair not doing resonance because it's away from the ring. Okay, now we can use what? Hydrogen and nickel and heat are going to all double bond going to reduce. This is a product. You got it, right? Now, next one, pyridine is very important. Pyridine N oxide. Okay, the question will ask in exam. Pyridine N oxide. Okay, the preparation must. Okay, please note. This is a pyridine N oxide. Okay, okay. Now see, we have to this like. This is plus and this is minus. Listen, note. Okay, listen. Nitrogen I will lone pair, right? Yes or no? They're going to give the electron because they accept basicity. This called donor ability. Okay. Now the exam they will ask the donor ability of pyrrole, pyridine, thiol, and what? And benzene. Okay. They will ask the pyrrole and pyridine and furan and thiol. Okay. They will ask the donor ability. Okay. This is based on the aromaticity concept. Okay. That lone pair involving resonance now. Okay. The aromaticity decreases. Okay. This is very important point. Based on that we can find out. Okay, in case of pyrrole pyridine la பார்த்தோம்னா okay, pyrrole pyridine furan thiol la பார்த்தோம்னா only the pyridine lone pair not involving resonance, therefore the pyridine is a more donor ability compared to pyrrole. Okay, this is very important point, please note. Okay. Now how to prepare the pyridine and oxide, please note the reaction. It's oxidation. Okay, we can use metachlorobenzoic acid. 1 2 3 here pyridine, here use metachlorobenzoic acid. What is MCPA na? Metachlorobenzoic acid, right? Now they form what? N pyridine oxide. Yeah, O minus, here plus. Okay, again we can use POCl3. We get again the pyridine. It's a reaction. Okay, this is important, please note, this is important, this reaction important. Okay, this is a the pyridine and oxide. Okay, this is a pyridine and oxide. Okay, now listen, again this first portion, second, third, fourth, fifth, sixth. Now note, very important point, very important, please note, the electron in pyridine oxide, in pyridine N oxide. Okay, the electrophilic reaction take place at fourth position. Okay, this is very important. Okay, I give an example. Same, this is a pyridine oxide. Okay, this is a pyridine oxide. Okay, you can use this reaction. Okay, I can use managed reaction. CHO and H, N, Me twice and H plus. What is electrophile? CH2 NH10S, right? Therefore hydrogen O minus plus inga CH2 N inga CH3 inga CH3. Okay, this is a type example for what? Example for electrophilic substitution in pyridine and oxide. Okay, this very important, please note it. Okay, next, indole. Okay, now what is the formula, molecular formula? One is 6-member ring, one is 5-member ring. Okay, one is pyrrole like structure, so pyrrole only. One is a benzene. Okay, this is a what? Indole structure. Okay, listen, now what is the position of indole? Please, very important, please, interesting. 1 2 3 4 5 6 7 8. Okay, now please understand, indole have 2 ring, right? This one, benzene and pyrrole. Okay, now therefore the indole undergo the both electrophilic and the nuclear substitution reaction. Okay, please note. Okay, but now electrophilic substitution is more important one. The electrophilic substitution reaction take place at 5-member ring, not 6. Okay, 5-member ring at third position. Very important. Okay, listen, third position. Okay, please understand. Now what is the answer? 1 2 3 benzene, pyrrole, idan indole, right? Allaya H dot 1 1. Okay, if I do the electrolytic substitution reaction, what is your product? Electrophile. Okay, 6-member one. This is a 6-member ring, right? This is a 6-member ring. This is a 5-member ring. Where is substitution reaction going to take place? 5-member ring la enna position? Third position. Okay, what is the 5-member third position? Listen, this is a 5-member ring, right? 1 2 3 here going to substitute, going to attack, right? Now what is the answer, please? 1 2 3 1 2 3. Here nitrogen atom 1 2 1 2. Now what is the answer? Answer is this question. Okay, no, actually you know, right, in pyrrole. Okay, where is the position going to take place? Second position. Okay, please understand. But in case of indole okay, that position. Okay, this is a very important point, please understand. Okay, very important point. Okay, if the third position occupy some molecule, occupy some group, then electrophilic substitution reaction take place. Second position. Okay. I give you the example, please note. Same case. They give this like molecule, benzene, pyrrole, 1, 2, 3, 4. Okay. Now listen. Here 1, here 2, 3, 4, 5, 6, 7, 8. Okay. 6, 7, 8. Now listen. Now going to substitute what? That portion is occupied. Right? I put here CH3, for example. Okay. This one. I put here CH3. Now, if I do a substitution reaction, ultraphile, now where is the portion going to attack? Generally, in pindole, okay, where is the portion going to attack ultraphile? That portion, okay. Suppose that portion occupies some other group, where is the ultraphile attack going to? Second portion, okay. Now, what is the answer? Tell me. Simple, right? Nitrogen, dot, here, CH3. Now, this is ultraphile going to attack this portion. Ultraphile. You got the answer? Okay. This is a very simple one, right? Now, last one, quinoline. Very important reason. Quinoline. Okay. This is what? This is a pyridine with benzene. Benzene with pyridine. Nitrogen, lone pair. Okay. Now, in this case, 1, 2, 3, 1, 3. Okay. Listen, please. Numbering problem. Okay. Numbering system. 1, 2, 3, 4, year 5, 6, 7, 8, 9, 10. Okay. Listen. In case of indole, we check. Okay. In case of indole C, this is a numbering system. 1, 2, 3, 4. Okay. In case of quinoline C, 1, 2, 3, 4. Inka 5. 6, 7, 8, 9, 10. Okay. Listen. In this case, this undergo what? Electrophilic nuclear substitution. Okay. Both reaction will take place. Now note, very important. In case of quinoline, very important. Please note. Just wait. In case of quinoline, electrophilic substitution reaction take place at benzene. Okay. 5th or 8th position. Now, why the benzene reaction will take place? Listen, we know, right? And pyridine and benzene, okay? Which is more electron density? Benzene, because the benzene having carbon and pyridine having nitrogen atom. Okay, nitrogen is more electron negativity compared to carbon atom. It means pyridine have less electron density. Okay, we know, right? Electron substitution always go for what? Go for the more electron rich group, right? Therefore, in this two ringler, which is more electron rich benzene, therefore the electron substitution reaction in quinoline, it takes place benzene. Which position? 5th position. Suppose 5th position occupy, go with the 8th position. Okay, simple. Now, the opposite. The nucleophilic substitution reaction and take place pyridine at second position. Okay, so very simple. In the example, you can use Chichiban reaction. Okay, what is the reagent? NaNH2 and ammonia. Just eat it. Which group going to introduce it? The NH2 going to introduce the second position of pyridine. Okay, you can write these two questions for the exam. Okay, answer. Okay, this is A, this is B, and tell the answer in comment section. Okay, this we can use NaNH2 and ammonia and just eat. Okay, tell the answer. In this question, we can use what? We can use okay, Br2. Okay, not Br2. Okay, Br2. You're going to get confused. Managed. Okay, do the managed reaction. In this question. Managed reaction. Okay, tell the answer combination A and B. Okay, now, okay, this quinol is over, right? Now I'm going to tell the very important. Okay, for example, if you're going to prepare the Pyrrole. Okay, which method going to use for the preparation of Pyrrole? That's very important and theory based question also in exam. Okay, this is a method of preparation at name of the synthesize. Okay, please note. Just wait. Now, just make it like a box. Just wait. Okay. Now, please note. This is the name of synthesis. Name of synthesis process way in a compound. Okay. If you want to prepare the Pyrrole, what is a reaction? That is called Conar Paul synthesis. Conar and Paul, P-A-L-L, Paul Conar synthesis. Okay. And second, if you want to prepare the Furan, what is a process we can use? Paul Conar synthesis. Both are Paul Conar. Okay. This is a Paul Conar process. If you want to prepare, okay, pyridine, very important. Pyridine and synthesis. Pyridine, N, okay. This is N. Just wait. Ends. Very important. This is important. As an example. H A N T Z. Okay. S H S C synthesis. Scientist name. Okay. Fourth, if you want to prepare indole, which you can use. Okay. Fisher indole reaction. Very important. This is also very important. Fisher indole, okay, reaction. Fifth one, we're going to prepare quinoline. Okay, this is crop synthesis. This is also important. Okay, this is important. Paul Conar, okay, sorry, crop synthesis. SK RAUP synthesize. Okay, sixth one, isoquin. Okay, this is not syllabus. Iso, but you have to know. Okay, this is a PIT synthesis. PICTE, PIT synthesize. Okay. This is a complete information about what heterocycle. Okay, this is very important. This you can use IIT JAM also. Okay, you can use CSR also, CSR GATE also. Okay, I give the complete information about what the heterocycle compound. Okay, I hope you understand, and thank you so much. Okay, see you in the studio as soon as possible, and Tata, bye bye, take care.